Hello everyone. In our last tutorials we have discussed about equatable protocol, comparable protocol. If not, please go through my earlier video tutorials on these protocols, equatable and comparable, where equatable is used for equality check and comparable is used for these operations check. And in this video tutorial, and we have also discussed that protocol comparable is extended from equatable protocol. So in this tutorial we discuss about the hashable protocol, which is like mostly it deals with dictionaries, sets. So for example, Swift's dictionary type places a limitation on the types that can be used as keys for a dictionary, correct? For example, if there is a dictionary, dictionary is generally like, for example, let's say if you say something like string, let's say another string or something like that is equal to, let's say, empty. So for example, this is the key and this is the value. So this dictionary type places a limitation on the types that can be used as a string, correct? So dictionary is always like key value pair, and key should always get conformed to the hashable protocol, correct? As described in dictionaries, the type of a dictionary's keys must be hashable. Why? Because this has to conform to hashable, then only dictionary will understand like whether a key is already there or not, so that it will return that particular value. So that means itself it can be uniquely representable. So that's why a dictionary needs its keys to be hashable, so that it can check whether the already contains whether it already contains a value or not for a particular key. I think without this requirement, dictionary couldn't tell whether it should insert or replace a value for a particular key, correct? So what I'm trying to say is, let's say for example, let me take a struct called just some test or something like that. Let is having id, let name, sorry, just a second. This id is of type int and this name is of type string, let's say. Okay, for example, if I, for example, let's say class, not struct. For example, if I give test, so it class has not, okay, let's quickly add initializers. We are not worried about this actually, but as it is complaining, so now you know, as you can see, okay, let it be 0. As you can see, now it will complain only about test does not conform to the protocol hashable. Why? Because this is the key, this is the value, and the dictionary key must be does not conform to hashable. So why? Because it must provide a way so that it can be uniquely representable. So these scenarios where we need this hashable protocols knowledge, where a type that can be hashed into a hasher to produce an integer hash value actually. So our own custom types also we can make them hashable by conforming to the hashable protocol. Then we can use, and when you try to add, first it needs this equal to operator. Why? Because as I already said, hashable is gets extended from equatable. So the hashable protocols inherits from equatable protocol, so we must also satisfy that protocol requirement. Now I would say like LHS dot id is equal to RHS dot id. So this is must. Okay, now I have written this. Let's see if it is doing any. Okay, fix. Okay, done. Type. Now let's see if it is again complaining. Okay, type test does not conform to hashable. So now let me run again and see. So the hashable protocol inherits from equatable protocol. So we have done the equality operator, but still it is complaining. Then what we need to do is we need to implement, earlier it's implement a protocol called func hash into. So this is just, let me write the piece of code, then I'll explain what I'm writing. So there is a hasher. So what we typically do is we combine id and we combine. So here we are just worried about id, so here we just combine the id. So based on the id we create a hash value. So based on that, this dictionary we give a unique value saying that see, now there are no errors. I think that's what it means, right? So this is what hashable protocol. First we need to conform to this, and so we are more interested in id value. When ids are equal, we are taking it as these are equal, so we are taking hash, and this is what we need to implement. So hasher, we combine the values. For example, if it is like, if it is something like lhs dot name also should be equal to rhs dot name, then we do like, we need to combine name as well. So based on these combinations, it will provide a hash id which is an hash value which is of integer type. So this becomes unique value for this key value. So that's how we can make our custom types, making our custom types hashable. Okay, so for structures whose storage properties are all hashable, for example, let's say class struct test, let's say struct so let's say it is also having integer, all are primitive types. Okay, so for structures whose storage properties are all hashable, these are all hashable. Of course, integer and strings are, these are primitive types, they are hashable by default. So we don't need to implement it. Why? Because for example, if instead of this, if I keep here and if I run it here, type struct text does not conform to the protocol hashable, it says. But what I do is, let me implement. Of course, I do this, but again I run this. See, synthesizes, correct? This is also a custom type, but synthesizes work here. Why? Because it is just having the primitive types. That's where every time when there is a structure, if the stored properties are all of or conforms to the hashable. Why? Because integer conforms to, it is unique, string conforms to the hashable protocol. So that is the reason. See, if you can see, both this structure and class are having the same type of storage property, which is the id, but which is then under the name. But as you can see, structure, when you conform it to hashable, it doesn't need this equality and this hash function, whereas class, it complained that you need to first do this. Why? Because hashable comes from the equatable, first the equality, and again we need to do this hash function hash. So that is the major difference between structures and classes, value types and reference type. So it gives an unique value when you combine this, and structures, that is the beauty. So now that is with the structures and classes. Now coming to the enums, when you define an enum without the associated value, it gains hashable conformance automatically. Okay, for example, enum test enum, for example, it is having case test 1 is equal to 0 or something like that, correct? Let me say, for example, it is of int. So case test 1, case test 2, correct? So let me see if I can use enum here. Okay, let me try to run it. Done. So it's not complaining. Why? Because these are custom types. This is of integer type, and if it is an integer type, it's automatically this is automatically hashable. Why? Because this is, so for enumerations without associated values, it is not having any associated value, it gains hashable conformance automatically, and you can add hashable conformance to your other custom types by implementing the hash into method. This is into, this is a hasher that comes, and you need to combine the values using which you want to provide the hash value. Okay, so we are all talking about so for structures whose storage properties are all hashable, and for enum types with all hashable associated values or normal values, the compiler can provide an implementation of hash into automatically. So having hashing a value means feeding its essential components, ID and name are the essential components, into a hash function represented by the hasher type, into a hash function represented by a hasher type. Essential components are those that contribute to the type's implementation of equatable. Associated essential components, this ID and name I am calling it as essential components. Why? Because these are the ones which contribute to the type's implementation of equatable. So if I don't mention name here, then the essential component is only ID. As we are having name also here, the essential component is name. So that is the so whatever you mention here, they will become the essential component. For example, if I remove this, so I don't need to pass this, correct? So as such, if I run it without doing, there is no error that will give, but to be frank, this ID we are concerned about, name we are not concerned about. So name we can remove it and have just the ID. So that's what hashing a value means, feeding its essential components. Yeah, so if you ask me what does it mean by an essential component, that means which are those that contribute to type's implementation of equatable protocol. So in this case it is ID, and of course any number of components that we can have. So two instances that are equal must feed the same values to hasher in hash into in the same order. Two instances that are equal must feed the same values to hasher in the hash. So that is the reason, first ID and then the name. So there is a relation between what we define here and what we combine here. So based on that, hash value will be generated. That will be very useful in case of dictionaries and also sets, which we will discuss in a while. So conforming to the Hashable protocol to use our custom type in a set or as the key type of a dictionary. Of course, we all know that sets are unlike list, like arrays. Sets will hold only unique values, correct? So what I mean is no duplicates. So how would structure know it that there is a duplicate that is getting inserted into it or not? So it's basically so here key should be hashable. So basically the one we are pushing into sets should conform to hashable, then only a set can check itself so that it will not have any duplicates. So these two are the main scenarios for the Hashable protocol, and this is the latest with respect to hash. The Hashable protocol inherits from the equatable protocol, which we discussed. The custom type, so Hashable conformance to adopt Hashable in a type that doesn't meet the criteria listed above, or to extend an existing type to conform Hashable. So we need to implement the hash function using the combine on the provided hasher instance with the essential components which we already discussed. To ensure that our type meets the semantic requirements of Hashable and equatable protocol, it's a good idea to also customize our type's equatable conformance to match, so that this and this will be in sync. So earlier if you have worked on Hashable protocol, there is something there is something we used to have, which is like hash value, but this is deprecated now, which is deprecated. Now it is hash into. This is what we are using currently. Okay, earlier there is something called hash value. Hashable is a protocol which provides the power to use a custom class object as a key. That means this will become, this struct test can be a key, test can be a key, test enum can be a key. So Hashable protocol gives us the power of using our custom object, a custom class or structure, or custom class structures or enums object as a key in a dictionary or in a set. So a type that provides an integer hash value. So this generates an integer hash value. Okay. So and there is one more thing, as per Apple, hash values are not guaranteed to be equal across different executions of your program. Do not that's the reason you are not supposed to save hash values to use in a future execution, correct? So for example, you run it in you run the app and it generates a hash value in the scenario, and it's not going to be the same for the next time you are going to run it, correct? So we are not supposed to save these hash values. They are not unique for each and every execution they differ. Okay, I think pretty much that's on hashable protocol, where it is pretty much used in dictionaries. If you are using a dictionary, so where it is used. Otherwise, for example, it's a set. Let me take a set and see. For example, let's say my set, let's say, which is of type set, and I'm sorry, this is how it should be, which is of type set and test. So if dictionary, this is one thing, and dictionary is one example, set we are discussing. So for example, let's say we are having test, so two instances. So let me add the initializers instead of giving these values. So I'll say initializer declaration. So id int name string. Now if I self dot id is equal to id, self dot name is equal to name. Okay, so let me build id1 name, let's say 1. Now let me try to let me try to do like this. Now let's see. Print so, but actually I am feeding it two test instances, but it is saying like the count is only 1. See, only one element it is taking. The moment I change it, it is taking it as 2. Why? Because it's a set and it cannot hold duplicate values, correct? These two are duplicate values technically. If I use same thing here, if you can see my set here, it is showing like id1 and name1, that's it, the count is 1. You can't cheat it. So these duplicates, how many you add, set is not going to take it. Why? Because my test instance is conforming to the hashable protocol. So this is the main use case. So for example, let's say this is something like it is not conforming to the test protocol, and this hash is not needed and this is not needed. Now test is not conforming to, so first in place it doesn't work. Like in dictionaries, see, this is what happens. Test is not conforming to the protocol hashable, test is not conform to the protocol hashable. That means what it is saying is, boss, this is where the hashable protocol comes, where if you want to use your custom class or any custom models object as a key of a dictionary or the or an element of a set, it has to conform to the hashable protocol. Otherwise you can't give it. The moment I roll it back, that means the moment it conforms to the hashable protocol, now yeah, this is deprecated. Now everything should work fine, all good. So if it is 2, now you can see like the number of items are only 2. Why? Because these two are again duplicates. If it is 2, again the number of items will be only 2. Why? Because there are again 2 duplicates. If it is 3, now then the number of items will be 3. Why? Because though it is 4, this and these are duplicates. So those are the use cases of hashable, I would say. So at very high level, the use cases of hashable, what we discussed, if you want to note it down, one is dictionary keys, which we just discussed. Second thing is, if it has to be a member in the membership, like in the sets which we just discussed it, my set, the hashable protocol is essential for determining whether an object is a member of a set or not. The hashing mechanism allows the set to quickly check for duplicates, otherwise it is very difficult, and ensure the uniqueness actually, otherwise it's very difficult even for dictionaries. Correct. And third thing is generally we do the caching, and if we are doing the caching, this is very important when building caches or memorization. Tables using hashable types as keys can lead to improved performance by quickly accessing cached values based on their unique hash values. Correct. So this makes it quickly fetching the cache hashable types. So hashable types as the keys, we design the database tables, then caching will become easy if they conform to the hashable protocol. So that applies to custom data structures also. Actually, like if you are writing a data structures, if you are designing your own data structures and need to ensure elements are unique, then what we need to do is a hashable will be crucial for implementing the hashing and equality checking mechanisms. So we need to remember one thing: when conforming to the hashable protocol, it's crucial to ensure that the properties used for hashing are also used in the equality check. So this is crucial. The properties used for hashing are also used in the equality check. Otherwise, you might encounter unexpected behavior in sets and dictionaries. So here, if you don't mention this and you add this, and you mention name here and you don't add the name here, or you just add the name here, remove the ID, then you will get unexpected behavior in sets and dictionaries. Correct. So this is crucial. This is very important. Earlier hash value that got deprecated, now is a hash method where a hasher comes, you need to combine the values that you have essential components we call. This is very important. That's how you make it hashable. Once you make your custom type hashable, they can be used as dictionary keys, sets, members of a set. You can use it for caching, you can use it for creating custom data structure, and Swift automatically synthesizes the hash value and double equal to methods for simple types like integer string, but requires manual implementation of custom types that we already discussed it. So earlier so that's basically so earlier this was starting from Swift 4.2. Starting from Swift 4.2, this is deprecated and this is the only way now. So pretty much that's on hashable. I hope it is not complex. Hashable is usually a nightmare for developers in using or in answering the questions in an interview. This is very useful, and there are 90 to 95% chances of you're getting asked about hashable protocol in an interview. So these are pretty much used in dictionaries, sets, where you will get questions such as, for example, I have a dictionary, I have a key, so what are the different data types that you can use? That means they are expecting you to tell them that this needs conformance to the hashable protocol. The same applies to the set. Correct. Why? Because set contains only unique list, so it will have that power only if you make it hashable. So dictionary will have that power only if you make this hashable, right? And this is very important, like the hash value, the ones you are using in the equality. Why? Because based on which you are saying that two instances of this are equal, that only you should combine. Correct. Otherwise uniqueness will not be built correctly, and you will get of course it will not give any warnings or errors, but you will get unexpected behaviors when using the hash value as per Apple's documentations and suggestions. Correct. So I hope this series of protocols tutorials are useful, like equatable, which is very essential for equality, and comparable, which gets extended from the comparable protocol, equatable protocol, comparable, and we can do less than, sorting and stuff, and hashable, which gets confirmed from the equatable, using which we can create an hash value for dictionaries and sets. Okay, so that's all for this tutorial. Thank you.